Our next speaker, please apologize if I'm not pronouncing the last name right, Erno Langenberg. Erno is an architect, researcher, and educator based in Rotterdam. He is the founder of the architecture office L Studio and is currently a researcher in digital fabrication at the Amsterdam University of Applied Science. He holds a Master of Science in Architecture from the Delft Technical University and studied at Aarhus School of Architecture in Denmark. His research focuses on the interplay between digital design and fabrication, combining programming skills, spatial awareness, and creativity with the aim of generating sustainable architectural solution and a new architectural language. At the Amsterdam University of Applied Science, he works at the Digital Production Research Group as part of the research program Urban Technology in the engineering faculty. His work involves researching in the use of digital fabrication to turn urban waste streams into circular products, thus improving the sustainability of cities. He also worked in collaboration with the European Ceramic Work Center in the Netherlands, exploring the possibility of 3D printing with clay for architecture, through which he gained experience in various techniques using ceramic production like slip casting, making plaster molds, glazing, and modeling by hand. I will leave the screen to you, Erno. Can you share a screen?
Yeah, I'm gonna try. So thank you for inviting me and the kind introduction. I really enjoyed so far the whole presentation of the whole symposium and also the great variety of speakers. So I'm going to add one more material to the whole day, and that's ceramics. And well, I have a slightly strange title for the presentation, but I hope it will become clear during the presentation. Do you see the next slide? Okay, cool. So, well, I thought maybe I introduce first a little bit the context of the work and my working, because since a few years I work at the Robot Lab at Amsterdam University of Applied Science, where we started from scratch to build up a robotic fabrication lab where we try to combine practice, research, and education. And we work with digital design and digital fabrication with industrial robots. We quickly grew, and we are still in the startup phase, but we work mainly with wood and printing, but especially the printing is still starting and mainly in plastic. So the project I will be showing you are a bit older. So therefore I thought maybe it also needs a bit of introduction, because the work is done in a completely different environment than the academic. It's done during several residencies, one at the European Ceramic Work Center in the Netherlands in 2014-16, and one in Cove Park residency in Scotland. So it's a slightly different work environment than the previous project. And also the approach is different. It was a more intuitive, design-driven approach, just finding out what one could do with 3D printing and ceramics. It all started with my fascination for digital design, and when working in projects in Africa, really building a hospice, and at the same time being introduced at the Fab Lab in Amsterdam, I realized, and I thought it could be maybe interesting to combine all these aspects and see if maybe through digital fabrication one could make architecture production a bit more sustainable and local again, instead of a kind of global operation where materials go all over the place. So thinking about this, I thought there's a kind of three aspects which combined are important and influence each other. Of course, there's the material affordance and the post-production and production processes and computational design. And I tried to combine these and see if they could inform each other and make the best of it. As a material for this research, I chose clay initially baked or unbaked, because it's a locally available material all over the world, and a lot of architectural applications as well, like roof tiles, bricks, and even interior like toilets and stuff. And when you look into 3D printing ceramics, you quite fastly realize that it's a kind of very old technique. Basically, it comes down to a technique which is called coiling clay, and it's one of the oldest techniques in ceramics. It's one of the first ones humans used to make vessels, and therefore it's also quite known, and a lot of people have this kind of tacit knowledge of how to use this material with line thicknesses and how to adhere layers. However, the aim was to do digital fabrication, so I was wondering what could this new technology and digital control add to the whole process. And of course, at the same time, architecture is not the same as a vessel, or so how could we change and form these objects so that they become a bit usable for architectural applications? So therefore, I thought the object needs to be opened. How can we produce these kind of porous structures I was looking for? And when you say digital control, you think that you have a lot of control. And when people also say that you can make anything when you start printing, when you start with clay, you easily get deceived, because there's a lot of things you can't print, like straight walls is very difficult. Of course, it is possible. And overhangs or bridgings are very difficult, maybe in other materials as well. So when you come across these kind of problems, there's different ways of mitigating this and going around, so to explore what is possible and if we can find other ways of doing it. So the projects I will be showing you are different ways of approaching these problems to make porous elements for architecture. So this was one of the first attempts where I tried to explore what would be possible if you would use the printing technology at that time available, which was, there was no stop and go yet. So we had to do a continuous printing process. And luckily, for example, clay is very malleable still when it's wet, when it comes out of the print. So you can easily make cross sections and interlocking tool paths, which also are very good while printing because it makes the print very strong. So after these ones, I thought, let's see if we can make something bigger, which looks a bit more like an architectural application. So it's part of a dome, which could be built out of elements with the intention to stack them without any glue in between. And this printing path, for example, was informed by the idea of having openings which could change according to the need of the structure to provide shadow or airflow. And for example, it didn't have any structural implications. The only structural element might be that the top layers are thinner. It has the same amount of layer, but because of the lower extrusion rate, the bricks become lighter because there's not so much weight at the top. Another project which was looking into this idea of making porous structures, and in a completely different approach, was the idea of adding another material to the mix, because in order to get ceramics, the clay has to be fired in the kiln, which at these temperatures, anything other than the clay will disappear, like any organic material will burn away, or some other material mixes will just pulverize into powder. So I thought this could be very well used to make porous structures if you could print the same two materials at the same time. So at the European Ceramic Center, we built a kind of a small or like simple dual clay extruder, and we started experimenting with materials, which appeared to be quite challenging because the material had to be both printable and also disappear in the kiln. And some materials unexpectedly became glazing, which was exactly what we didn't want, of course. However, in the end, we did find some materials which were working. we found a kind of organic mix which was disappearing in the kiln, but it was rather hard to print. And the best was working a kind of inorganic mix of bentonite and some other ingredients, which then in the oven pulverized into a powder and easily released the printed form. And well, this was all we could do in the limited scope of the project, but I think it's a kind of potential to find another material, but we need further research into this. One kind of aspect which came out of this project was that because we had to change the tool pathing and another way of printing, I also discovered that you could also make other shapes. And this was just a kind of formal exercise into finding out if it was possible to change the look of these printing elements instead of having this aesthetic of horizontal layers. I thought it would be interesting to see if you could print something on the outside of the existing print to change this aesthetic. And also this, the continued improvement of control over the printing during time was the reason for the next project, which was explored in Scotland, which was another way yet of trying to open up this prints, open up the vessel. And my idea was that if you would alternate the layers, direction, each layer, you would open up the structure because air would go through. It's like stacking like sticks on top of each other. However, the material clay doesn't bridge very well, as we've seen in the beginning, but in this case, it became a kind of controllable feature because it doesn't bridge very well, but it always collapses in the same way. So it's a kind of controllable element you can play with and still have an open structure. So in the end, I discovered that if you would just repeat the same structure, the same script in different variations. So these are, we call 24 elements in stoneware, but with the same script with different variations. And you clearly can see that it becomes a kind of ornamental column with a kind of predictable outcome, but also some kind of organic feel to it, which I thought was kind of appealing. And one of the last techniques I explored, I'm showing you is a bit more recent, is the idea of printing within a mold. It's also done in classic ceramics, like you could coil by hand into a mold or pour liquid clay by hand. And of course, while doing it with a machine, you have much more control over the whole situation, and you can make very intricate, complicated shapes, like this one, for example. And these ones were not meant to be architectural objects; they were meant to be plates. But I can easily imagine the application for architecture because if you have a mold, you can customize, mass customize in a very flexible and fast way a ceramic facade element, for example. The last project I want to show you is a non-finished project. It's actually only a sketch, but I thought it would be interesting in the context of this symposium. It's the first time I'm showing it because it's rather new, but it's a commission by the organization called Fabrikator and located in Nijmegen in the east of the Netherlands, close to in a river landscape. And they try to explore what you could do with local clay from the river. So they ask artists and designers to come up with solutions or ideas what to do with their clay. So projects were done with throwaway coffee cups and plates, and also printing with ceramics with the local clay was explored. So they asked me to see if they could maybe scale up this use of the printer and see if we could make an architectural element this material. So they're located next to the river, and this is their well, laboratory where they produce stuff. And we came up with the idea to make a facade tile for one part of the building, not to make it too complex. And it's of course it's an existing building, so the facade element would be only a decorative element. It's just to try out. And I have to go back. Yeah, one of the ideas is that it would be made very locally, so that we use it with the material available there and also the tooling available there. So everything would be customized. And if you would do that, on the top left is the starting point, or if you would tile it in some kind of way, you would have always a lot of exceptions, especially because the building is an existing building. Yeah, you can imagine that it's not straight in all the places. And there was also, I thought maybe if you could scan it and then get a really accurate reading of the existing building. But one idea is that, of course, for the 3D printer, it doesn't matter, you know, to make exceptions and making strange prints. But then I thought, like, yeah, why bother to make square ones to begin with? So let's try and make all of the tiles exceptions. And then we can make a kind of funny and smooth transition between the rectangular outside of the building and the curved inside of the building, curved arch opening. Create a kind of wavy pattern. Unfortunately, the building had to be taken down, so we're still waiting for this project to be continued. But we're sure at the summer, next summer, they will move to a new location and we continue the project and see what we can do there. But the reason why I was showing this is because something else previous speakers have been talking about, because of the process and the printing times. Because in this kind of project, because we wanted to do it locally, there were only limited resources available. So you start digging, you prepare the clay, you 3D print, you fire it, and the idea was to glaze it with local materials, fire it again, and then you mount the tiles. But when you start adding all this up, if you have only one printer which was available, and a limited amount of size tile, like 30 by 30 centimeters, you would spend 30 full days printing, because you cannot leave the printer unattended, so you cannot print through the night, which is a bit difficult, of course, and it didn't fit in the time frame of the project. So I thought already, if you would make a little print farm, it would already be a bit more acceptable. A week of printing, you would say, okay, well, so that would be feasible, no? And the kilns would not be a big problem because you can leave them unattended. Having said this is only just a little facade. Oh, I'm running out of time. So I thought, what happens if you would print in this fashion a whole building? I did a quick, very scientific Google search, and the first hit was that it said 8,000 bricks are needed to make a single house. If you would do it in this way, like I just described, it's fairly impossible. You would need 500 days of printing. So that leads me to the last slide, and that's mainly a bit of a discussion plate, which is where would we go if we would really be serious about using ceramics in 3D printing ceramics for a building environment. A small scale project you can easily do like I described before, but if you want to scale it up, building size, you need a different process, especially because ceramics is different than the next project. For example, you need a kiln to fire the pieces. So I think we have to think about how to implement this printing in a existing or a new industrial environment, and maybe possibly also involve robotics to pick and place all the 3D printed pieces and put them in the right place. Okay, so I think I'm done. Yeah. So that was it. I thought I'll leave this up for discussion, and I want to thank you for your attention and see whatever questions come up.
Thank you, Erno. Very interesting project. So you also came back to it yourself. I was surprised when you were showing the small tiles, and I was like, why would you print such a small tile with 3D printing when you can print larger? Obviously, you need the oven. And I'm just wondering if you're thinking, well, I have two questions. One, do you think there's other ways to cure the material beyond the way we are doing it right now as we are printing?
You mean the clay material?
Right.
Well, you could leave it unfired, but then it will slowly disintegrate, and depending on the climate you're in, it will take longer. Or in Holland, it would take it will disappear quite fast.
Right. So I mean, the room, the heating room will be the constraint of the size, right?
Yeah, and there's different ways. I mean, in the industry, there's a kind of like yeah, it's like a factory. No, the tiles go in a big machine and they come out baked. So, and there's all kind of things in between. You have the small one, which was available at the location, but you have slightly bigger ones. But I think it's unavoidable that you fire the bricks.
Right. And then also on the other hand, there's also a shrinkage as soon as you fire them. And how would you count for that right now as you're working on this facade, let's say? Like, are you having that as part of your design tolerance or?
Yeah, for sure. Well, you know upfront the shrinkage, so you could calculate for that. You can just make your pieces bigger, print them bigger. But this, of course, you have to find out because for how would you say that mixes you would buy from the shop, you know exactly the shrinkage. But because this is a locally delved clay, it's a bit more unpredictable. So you would have to do some tests before.
Yeah, that leads me to the question of the material mixtures. You said like you want to emphasize the local materials, yeah. And I guess for 3D printing the clay, you need to have a very consistent material quality somehow. So I was wondering if it like how much work it is to make the local materials really work for the 3D printer, or do you use any do you add anything to these materials? I really enjoyed also the study of the dissolvable or burn away materials. So can you expand a little bit on that?
Well, you have two questions, but
yeah.
The first one, well, I think it's not super critical, the material to print with, as long as it depends, of course, a bit on the nozzle size. But if you scale it up a bit, most of the prints will come out. And the clays I used so far are non-treated. We didn't add anything except a little bit of water to make it a bit more smooth to come out of the printer. So I think that's not really a big problem. You do, however, if you really dig the clay just out of the river side, you have to clean it. No, of course, from stones and all kind of other organic materials which are in there. And the other one was not really a question, was it? Was you asked me to elaborate on the?
Yeah, I mean, in general, this idea of creating new materials that interact really well with clay somehow. Yeah, you mentioned this burn away material, this more organic material, because I was thinking, yeah, I mean, in concrete, you see that there's a lot of material scientists that contribute to optimize concrete for the 3D printing process. So I was wondering what is going on in clay and ceramics in that domain of developing materials for it, or additives kind of.
I'm not sure. I think it's well, I might not be aware of all kind of material experience all over, but as far as I know, it's quite basic. There's of course additives to clay, and it's mainly to make it more stable during production. You can add already fired clay to it, like little grains. And I've known some people added some alcohol to the prints to make them dry faster. That's as far as I know of it.
Yeah,
But,
because I was just going to say, as soon as you start scaling up, you will deal with deformation, and you need to kind of deal with curing the material as you print higher, right? And it's not, the shrinkage will occur while you're printing as well as when you put it in the oven for it to cure. So it's kind of a complicated, it's a difficult material to work with.
Yeah, for sure. It's a very difficult material because it shrinks while printing it and in the oven. And also depending on where in the oven. So I think in the end, if you will use it as a building material, you need to account for quite some tolerances in your design.
Yeah.
But it's not really a big problem, I think.
Yeah, there've been some very nice project on clay facade I've seen been going on, which was interesting. We've been testing, and there has been like loading of material constantly. That's another issue because you want to pump the clay. The viscosity is another issue, whereas with concrete, you can pump it and then you add mixture at the tool head. And here you are dealing with the very different, in some way similar, but very different complexity to pump clay, for example. I'm not sure you're even pumping it right now. We haven't pumped.
No, it's not. No, it's not really. Yeah, it comes from a cartridge. It's kind of pumped. But right. I think eventually, if you would scale up, you would get a bit more, because I've seen factories where they make ceramic building elements for skyscrapers, and it's not, they also have their big storage and big extrusion profiles. So if you would end up somewhere in between these two, I think it could have a big potential, because this technology of extruding clay is not very new. It's just a completely different scale than the printing, I would say.
Right.